recording here. And let me give you a moment to copy this example down, and then we'll take a look at it. Okay, so, well, we got to look through formulas and try to think here. Samuel thinks maybe 91. Okay, let's put some candidates down here. 91. Jacob said 88. Leping 88. Hold on here. Let me see. Let me see here. Maria 88. Okay, we're getting a lot of 88's very popular here. Hold on here. Let's see. Okay. So it looks like it's between 88 and 91. Okay, between 88 and 91. Okay. So, well, so formula 88, let me just write that formula down here. Hold on here. Okay, so formula 88 is the antiderivative of cosine of du is equal to u times the arc cosine of u minus the square root of 1 minus u squared plus a constant. Okay. Now, I claim that although formula 88 is close, it cannot be used directly to find the antiderivative of this problem. And by the way, the 5, we know we can bring the 5 out front, right? So, but this formula, it's close, but there's a problem. There's a problem with formula 48 in regards to using that for finding the antiderivative of the arc cosine of the square root of x. What do you think the problem is?
The square root?
That's right, Sophie, the square root of x. So we have in formula 88 the arc cosine of a variable, but the variable u. So, but the problem is we have not just a variable x here, we have a function of the variable, a square root of x. So let's see if maybe formula 91 might work. Let's see, that's the other choice. So let me go to the next page here in the solution. And basically what I've written here is what I just stated, but I'll only give you a moment to copy it down formally. Whoops, hold on, don't do that. Don't do that. Hold on. Okay, let me give you a moment to copy this down. We learn we learn, I mean, writing helps us learn too. Many of you are probably, well, many of us are kinesthetic learners. That means we learn by movement, and writing is moving. So it actually helps. All right. So we've discovered that Formula 88 can't really be an option because our integrand is the arc cosine of the square root of x, not the arc cosine of x. Okay, well then, what do we do? I mean, here's our, here's the problem that we have to solve. What are we going to have to do to help us here?
Substitution.
Substitution. All right, Samuel, I like that idea. What would your substitution be?
Root x.
That's good. I mean, there's really no other choice, because the formula 91 also has an arc cosine of u. So we have to let u equal the square root of x. We have to make that substitution. And so we'll do that. We'll do that. And I show that on the next page. Let me know when you're ready to go to the next page, and we'll move forward here.
I have a question, Professor. Can you elaborate a little bit on why we can't use 88?
The problem with 88 is Formula 88 has well, it's the integral of the arc cosine of u, but we have the arc cosine of the square root of x. The square root of x is very different than, like I can't make the connect the square root of x to the u. I can't use this formula because the square root of x, I mean, what I'm trying to say is I have to this Formula 88 and Formula 91 as well requires arc cosine of a variable, not the arc cosine of a square root of a variable. You see what I mean there? And so we can't have the square root of a variable. Now we can let u equal the square root of x, and then with that substitution, that'll work. But we can't just apply the formula directly with the square root of a variable. Does that help you?
I mean, is it safe to assume that just because it's a composite function, we have to have, I guess, an additional u in the front?
Well, what the hope is then is naturally I'm going to let u equal the square root of x, and then hopefully the u and the du will get absorbed. So I'll show you. It's a good question. Let's go to the next page, everybody. Let's try this. We're going to let u equal the square root of x. Oh, well, that's x to the half. Okay. And when I do that, du dx is 1/2 times x to the negative half power. That means du is 1/2 times x to the negative half power dx. All right. So what I have here with the substitution is I have here the arc cosine of u. But now the dx has to be also taken care of. Well, if I want to get then if I want to get the dx by itself, since I have a 1/2 times x to the negative half power there, I have to multiply both sides of this equation by 2 times x to the half to get the dx alone, so that dx then is equal to 2u du. And so my integral now is going to equal 5 times the integral of the arc cosine of u times 2u du, and that just equals 10 times the integral of u times the arc cosine of u. So it worked. It worked. We can use formula 9. So all the problems, in section 5.8 with the correct substitution, it has to work out that you can use one of the formulas in the table of integrals. Nathan, are you a little more comfortable now with the procedure?
Yeah, I was hoping there was just general advice.
Yeah, it really is like, well, if the formula has a u in it, and your integral has a square root of x, you can't use the formula directly, because the u is a variable, but it's not the square root of a variable. Think of it like that. It's
Okay, thank you.
okay. All right. All right. You're welcome. So, okay, so now we apply formula 91. We apply formula 91. So hence I have the 91. When I apply the formula above the equal sign, I put a 91 with a circle over it, and I would want to see that in your you should do that in your homework. You'll want to on your exam, right? You'll do that, and we get this, and now u is equal to the square root of x, so I put the square root of x back in for u. Okay, and so so we get here. And naturally, I'm not going to want, this is my integral, but I wouldn't want to type all of this in WebAssign. I'd like to, simplify things a little bit. And I do that on the next page, but let me give you a moment to, let's see if there are any questions. Okay, who's comfortable so far? Okay, Maria's good, and Audra and Renat and Tall, Nicole, Leping, wonderful. Jacob. All right. May I move to the next page? Okay, good. All right, very good. Thank you, everyone. Then to the next page we go. And what I do is, the square root of x times the square root of 1 minus x is just equal to the square root of x times 1 minus x, right? And so I can distribute to 10 as well. I mean, this is really cool, right? And in the end, of course, 10 over 4 is equal to 10 fourths, simplifies to 5 halves. Okay. And the same here, 10 fourths simplifies to 5 halves. And we're there. We don't forget our constant of integration, of course. Okay.
I have a quick question.
Yes, Thomas.
It's more related to the exam because I'm just looking at this work right now, and
Hold on a minute. I want to answer that question. Good, Thomas. Let me get that. I'm going to answer that question. I promise. I promise you. Hold on to that thought for just a moment. Class, are there any? I'll stop the recording here. Are there any questions on this? May I stop the recording? Okay, I'll stop the recording.